We are joined by Amanda from Data Visualization Society. We're super excited to have her, and I'm really looking forward to her talk. So I guess, Amanda, without further ado, I'll turn it over to you.
Great. Hi, everyone. I'm excited to be there. Teresa, can you just confirm you can see my slides now as well as my video face in the corner?
Yep, we can see your slides and your video.
Perfect. So I'm excited to be chatting with all of you today. I am Amanda Makulec. I am the Executive Director for the Data Visualization Society. We're a global professional association for anyone doing data visualization, and we'll talk a bit about what that looks like and what that means as part of this talk. But we are a global association. We've got folks from over 90 countries around the world, over 22,000 members, and it is a wonderful space to be able to be a leader in and be a part of the community on, because data visualization is something that connects to so many people in their work and our lives these days. And we'll talk about that too. So today in my talk, I'm going to talk about how you can think like a data viz designer and give you some hopeful tips and tricks that you can use if you're building various different dashboards or static graphics, or if you just want to be a more informed reader of charts and graphs. Maybe building data visualizations isn't your jam. That's okay. Hopefully this talk will help you be more aware of the ways in which data visualization can be interpreted and used in the world around you. So my outline for today is going to be three kind of key things. We're going to talk about the evolution of data visualization, because I think it's good to level set on some terms and talk a bit about our history before we dive into the world of data visualization today. Then I'll talk specifically about how to think like a data viz designer when creating explanatory charts, the charts and graphics that you see in spaces like data journalism or static reports that allow us to report on key analysis findings. We could keep diving down many different rabbit holes into the worlds of exploratory visualizations and scrolly telling and data art. But we're going to focus today on those explanatory charts and graphs that help you communicate an analysis finding. And then last, I want to highlight three big sticky considerations we think about when creating visualizations. I think sometimes we do a disservice as data viz designers when we talk only about the chart creation components that go into our aesthetic decisions or our chart selection, and don't talk about some of the bigger challenges and conversations happening within our industry and within our community. So with that, let's go ahead and get started. So the evolution of data visualization as a field and what data visualization is. I imagine almost all of you, if not all of you, have looked at, read, engaged with a chart or graph, especially over the course of the last 3 years of the pandemic, where we've seen a huge volume of charts and graphs created around COVID. And as we think about the evolution of data visualization, it's important to think backwards beyond the world of computer graphics. I think some histories of data viz kind of harken back to when we started creating graphics with the computer, or maybe back to some of the hand-drawn maps like John Snow's cholera map back in the 1980s, or Florence Nightingale. All of those are wonderful people to celebrate, but data visualization goes back even farther. Ever since the very earliest days of humans, we have found ways to track information visually and to count things and to make marks to count and itemize things. And so as you think about data visualization history, I'd encourage you to think broadly about what that looks like and what that means. And you can find an entire section all about data visualization history and people in it on nightingaledvs.com, which is the journal for the Data Visualization Society. Elijah Meeks gave a talk a little while back, though, at the Tapestry Conference in 2018, talking about the three more modern waves of data visualization. And these sit in the space of about kind of the 1960s, 70s, 80s onwards to today, where we have something that is the emerging world of computer graphics. He talks about the first of the three waves being focusing on clarity. How do we create greater clarity in the graphics that we're creating? The Tufte visual display of quantitative information, the work of Stephen Few, and also some of the more recent work of Cole Nussbaumer Näflich all fall into this bucket. These are all people who have talked about how we can simplify the graphics that we create to take away the chart junk, as Edward Tufte would talk about, or really to declutter charts and graphs to focus on the key messages. And as you can see, I mean, Cole Nussbaumer Näflich is the author behind Storytelling with Data, and he has a very kind of modern contemporary of people in data visualization, whereas the first iteration of Tufte came out in the early 1980s. So these waves are not concurrent, but rather things that can continue in terms of their impact on our work. So we focused for a while in data visualization around clarity and how do we make clearer charts and graphs. There was a second wave in the field that focused more on systems. How do we reshape the ways in which we structure how we think about data visualization and about how our tools think about and create visualizations? Here you have things like the Grammar of Graphics by Leland Wilkinson, which is the concept and framework that underlies the ggplot environment that's used by people who use R for analysis and plotting, and looking at other library-based visualizations. The idea that we can create systems and structures and reusable code and language to talk about the various encodings in our charts and graphs. Then we have this third wave of data visualization, which is where we start to see a lot of the different disciplines in the industry kind of converge and come together around different things. You see notebook-based platforms like Jupyter Notebooks and other collaborative analytic notebooks getting more dashboardy in nature. You see various BI tools like Tableau becoming more custom and being hacked and used to create more custom artistic visualizations. And you see these more funky analytical applications. And there's a lot of conversation now about what it's going to look like, the world of data visualization, as we look forward to how AI will influence what we do and how our ways that we conceptualize and visualize information may continue to shift and change as the world of virtual reality becomes something that people engage with more. So we see this convergent where all these different kind of groups and these kinds of visualizations all come together. And that third wave is really what the Data Visualization Society was born out of, trying to say, instead of being in these tool-specific silos like the Tableau community or the Power BI community, we all have things that we can share with each other and shared practices where we can learn from each other, which is a really exciting space to be in. Right now, as a global community, we really spend more time than ever looking at visualizations of information, even when we don't entirely conceptualize that we're looking at charts and graphs. We certainly see them in places like work, where we look at dashboards and other ways that we look at analytics and tools to understand what's happening in our work. But we also see them in the quantified self components, the closing the rings on the Apple Watch that you see for some folks, or on Fitbits, or other ways that we quantify our daily lives. We see them in ways in which entertainment is being visualized and spoken about, even down to the fact that Spotify assigns a emotional valence score to all of its songs that you can actually download and analyze, as Lindsay Poulter did in one of her award-winning visualizations for Tableau's Iron Viz feeder. And we've used it over the past 3 years around assessing risk. It's worth flagging, I think, that my actual background is in public health. I have a master's in public health and a degree in zoology and sociology. So my background's not in analytics or data visualization, but rather in all of the ways in which we collect and analyze and communicate data, and eventually kind of evolved into a career in data viz. And if you want to dive into that, I'm happy to chat about that a little bit more at the end of the talk. So as we think about data visualization, we are seeing the ways in which our field is evolving to communicate information in new ways. And if you want to see examples of that, you could go ahead and poke around just at the DVS Annual State of the Industry Survey Challenge, where we see people using things like embroidery to create visualizations out of embroidered threads. We've seen Play-Doh visualizations and other things that may not be what you think of when you think of charts and graphs. All of this has kind of come to this space where nowadays we think about data visualization as a skill, kind of like writing as a skill that you have that can make you better at your job if you're a good writer. But it's also something that can be a full-time job for different people. And when I was in college, I didn't know you could be a full-time data visualization designer. That wasn't something on my radar, or a team leader who did this kind of work. And so it's been interesting to see this kind of evolution of the field and working hard as a community not to ignore the fact that even if you're not doing data viz full-time, it's important that you build your skills and knowledge around how to do this well. We see the ways in which visualization gets used across fields, from data art and to research and evaluation, to UX, graphic design, business intelligence, data journalism, and more. And there are so many different pathways you can take to work in the field of data visualization, whether you're a designer, an engineer, an analyst, a teacher, or a developer. And if you're creating explanatory, exploratory graphics, or you're working with more conceptual ideas or quantitative information, this is just a short kind of quick snippet of the various different titles you might find if you looked at the world of data visualization creators, data artists, data analysts, data journalists, science communication designers. And what we create, as we start digging into the things that we build and the ideas for you for how you can think like a designer, may look different depending on our role and depending on our audience and our training. Something a scientist is communicating to a very technical audience might look very different from the final output of the same exact data by a designer. These three panels look at examples from our chart chat with the Atlas of the Invisible Authors, looking at the ways in which they evolved a visual concept around the pukier skies, as you can see with the puke green, which is a very nice design feature. And I firmly believe, and that's why I'm talking to you here today, is that anyone can learn the art and science of data visualization. And you can really master those fundamentals rather rapidly. You can build better charts and graphs tomorrow, based hopefully on some of the things that you hear today. But then you can spend a lifetime really refining, iterating, and evolving that kind of practice and what your own aesthetic choices look like. And the more you learn and master some of the fundamentals and the rules, if we call them that, of data visualization and understand the science behind the choices we make, the more you can learn when to break them. You'll also see that a lot of tools, Tableau, Data Wrapper, Power BI, Click, Infogram, will make these promises around being so intuitive and easy to use. But I want to assure you that they kind of are and they kind of aren't. And the role that you play as a data viz developer, designer, creator is really important because you understand your audience and their needs and your analysis goals in ways that a tool probably never will in at least the short term. I haven't seen ChatGPT-4 master how to go ahead and perfect the art of customizing by audience. So as we think about what it looks like to learn data visualization, I think people often think of it as this very kind of linear journey and a linear path. But really, we oftentimes are shaped by what kinds of visualizations we want to create and the industry that we want to work in. Working in public health, I worked a lot with tools like Excel, but also tools like Stata, rather than working in something like R, just by nature of what my industry was demanding. And what you want to create, whether it's interactive and scrolly or it's static, will drive some of your tool decisions. And so if you're thinking about a career or ways in which to give upskill in data visualization, you might start from a place of learning, say, Tableau, but then you need to learn other tools to support your use of Tableau, SQL, Figma, Alteryx. And then you explore Power BI for other dashboard projects. And then you want to make more kind of static graphics and dig into things. So you look at raw graphs in Illustrator. And this exploration keeps on going. And I raise this in part because the things we talk about today in terms of practical things you can do to build any chart or graph, you can use in any of these tools because they're ideas and concepts and fundamentals. And so as we think about what the real career journey looks like, for many of us who are in data visualization, it's not been one that is linear, but rather one that takes a lot of twists and turns and doubles back on itself. And so if you invest in this foundation of fundamentals and data visualization design and try to learn how and why we think in different ways and make different decisions around purposeful color, information architecture, the Gestalt principles, you can design more effective visualizations no matter what tool you are actually using. So my advice today is something you can apply regardless of the tech stack that you might work in. And I will say that I still do a lot of things in Excel and PowerPoint because it's there, it's present, and it's widely usable by a lot of the clients and teams I work with. So let's talk about why we're wired for visual information and why we like data visualization so much, because we do like data visualization a lot. We are visual processors as humans. The two optic nerves in the eyes are sending what we now know are 20 megabits a second of information back to the brain. And that means the speed at which we're processing information visually far outpaces any of our other senses, with conscious processing through our ears or our auditory processing being the next up in terms of our conscious processing speeds. But the subconscious processing and our ability to see and quickly intake information, if you don't have a visual impairment of some sort, is exceptionally good. And we will interpret and think about and see patterns and information before we even realize we are seeing them. And there are certain features of visualizations that help us understand why some visuals just seem to be more intuitive to us as people. And those are various pre-attentive attributes, or this idea of thinking with your lizard brain or your amygdala that allows us to do this precognitive processing or process information in our subconscious. So I want to do a quick exercise where you can sit and you can look at the next slide. I'm going to ask you to count something. And I'd like you to count the number of times the number 5 appears on this table. You're probably maybe finishing your counting right now. I don't care if you got the number right or wrong, What I do care about is if you think it is faster or slower to count the fives this way with the table formatted just such, or if we start to highlight the number 5 in color. Now, assuming that you trust me as a data viz designer, and I should do this at some point and try to trick the audience and not color in one of the fives. If you trust me, you no longer have to read the numbers. You can just skim along and look at the table and see the fives that jump out at you and quickly count the number of kind of blue squiggles you see without actually even reading the numbers themselves. And that's in part because color is a really powerful pre-attentive attribute that allows us to quickly see patterns and information. We can look at color in the form of hue, lightness, saturation, intensity. And we can then start to think about the ways color layers into other kind of pieces of information and other pre-attentive attributes like location. How are we positioning information or marks in space? We can clearly see under similarity that we have 40 separate dots in blue and in gray, so 2 groupings by color. And we can start to actually group them all together to say they're all similar in some way, or start to organize them differently and show that maybe the 2 different groupings that are separated by some white space show us 2 separate groupings of information. Using closure or a box around data points to show us which pieces are connected. Looking at continuity through a set of data points, or connection, where you may actually read in this lower right-hand corner, you may actually read that as 9 different symbols or 3. And you probably read it as 3 because there are lines connecting the circles and the triangles, rather than seeing that as 3 circles, 3 lines, and 3 triangles. So we think a lot about spatial grouping in data visualization, including how things cluster like marks on a page, but also on, say, a dashboard. How do we actually position different charts and graphs together to be read as a group? We think a lot about form and about the ways in which we use length, position, area, angle, line weight, and other visual forms to represent information. You'll note that the figures represented in all of these graphs are the same. Some of them are easier to compare, say, A versus D than others. And that's by nature of some of the forms being more visually precise in terms of our ability to compare them. We're actually really bollocks at comparing area of circles. We're very bad at that as human beings. And the last pre-attentive attribute I'll point to is motion. And the idea that we can actually encode information, encode motion, or encode data in motion such that the speed of these dots or balls as you see them falling actually means something. It's not just them moving through a pathway, but it's the speed at which a process happens. And motion and animation are really powerful for grabbing our attention and watching something happen. So think about the ways in which you might incorporate more innovation in data visualization, like motion or data art, into your work. So once you start identifying these pre-attentive attributes, color, form, through positioning, motion, other things, that in charts that you find easy to read, you'll see them everywhere that you look, and you'll see the ways in which they get used in graphic design and wayfinding your way around the world. So we take all of these different encodings, we think about layers and color and position and size, and we really combine all of those encodings, which are named very, very specifically in the grammar of graphics, into charts. And oftentimes, if you're someone who's not sitting in the world of data viz all the time, your introduction to visualization is in the form of thinking about what chart to use for what purpose. So the question I often hear from people is, which chart type should I use for a given use case? And the answer that you'll hear from me and many other data viz designers is it depends on a lot of features and questions. You want to ask yourself about what kind of analysis finding you're trying to illustrate. What is it that you're trying to show? What kind of relationship or what kind of distribution? And we can look to tools like chart taxonomies, which classify and group different charts according to function or other features like shape. And those come in the form of static taxonomies, like the Financial Times visual vocabulary that groups various different charts into groupings like change over time or part to whole. If you scan across this, you'll actually see that bar charts pop up a lot across the entire grouping, and that's in part because they're good for so many different purposes. That's why we see them so often in reporting and in data journalism. There's also interactive tools like the Data Visualization Project that will allow you to actually go and drill down and look for and search different charts based on function, like part to whole. Or you can drill in and look at even more detail about the ways in which data might need to be structured, or if you scroll down on that page, examples of different donut charts. Or you can go ahead and search on other bases, looking at other functions, but also looking at things like shape. So if you want to find a circular chart, you could do so there. We can think about the various ways that we start to reinterpret some of these chart types into components of, say, a dashboard, if we were working on something like a dashboard for monitoring a situation. We think about bands, big awesome numbers, or sometimes replacing the awesome with big ass numbers, but big awesome numbers, which oftentimes are presented at the top of a dashboard or on a report to provide quick key performance indicators on some piece of information. But a number by itself is not worth very much. There was conversations with many people, including Hans Rosling, about the ways in which a number without context is just a number. And so we want to think about the ways in which we add visual context to those big numbers. If we want to go ahead and tell a story about what's happened over time, we may want to add visual indicators like arrows pointing up or down and coding information with color or direction, and things like sparklines or small area plots that allow us to see trends and information. We don't want to just give our user a number. We want to help them interpret and understand what is happening. We think a lot about change between 2 points in time or two different categories. And we think about the ways in which we plot and look at change. We can look at change at really micro levels in a data set at the customer or member level. We also can look at it at larger changes or trends over time. And when we look at these things, think about all the encodings we have for change. You could have a comet plot, a lollipop chart, a dumbbell plot, a dot plot, connected dot plot, a paired bar chart, a slope graph, an area chart. There are so many ways if you start to just look at change between 2 points in time that you can visualize that. And this is where starting to understand which of these are more effective in different cases, and also which of these will best resonate with your audience is so important. We think about looking at things like a distribution and showing all of the data in a dense data set. And in a great article from Nick Desperatz, he writes about the ways in which box plots can be misleading because they make two groups look almost identical, even though those two groups, if you look at the underlying distribution of, say here, study participants by age, are not. And we've seen a lot of conversations in the data viz field about the constraints and challenges of using summary visualizations, box plots, or bar charts, because of the ways that they obscure what we might understand or interpret to be beneath them. Eli Holder and his team did a piece of research actually looking at the ways in which people interpret and understand bar charts and looking at measures like average income across 4 different groups. And we naturally, as humans, the way that our brains work is we interpret that when we see the end of a bar chart that indicates a mean number for a population, we assume everyone clusters around the end of that bar. When in all actuality, that might not be the case. And the challenge is that can reinforce deficit framing, where we may think of, for example, all of the purple people are smarter than the green people if we associate income with intelligence. And so the challenge that they looked at and the hypothesis they tested was if charts could encourage misperceptions of dispersion, this idea that people cluster versus are being distributed more. And I raise this because one of their suggestions in terms of things to do was to go ahead and do things like bee swarm plots that allow us to go ahead and see all of the dots plotted for the individual people and to see where those clusters, but also see the range represented and see the distribution of data points. And as you're working with community measures or metrics or other things that involve comparing different groups of people, I think it's really important to be mindful about the ways in which someone might take a step further in how they interpret a chart or graph that focuses only on summary statistics. We make comparisons where we compare different categories and oftentimes want to find ways to provide reference point for what those categories mean so we can interpret and understand whether a measure is, say, good or bad. And we layer things together in small multiples where we'll use panels of charts of the same type and structure that show different information, where you learn how to read the chart once and then can apply that mental model across other charts. We've seen this happen in a lot of the reporting that happened around COVID. Again, my public health background sends me to these examples because I spent a lot of time with them over the last couple of years, where we looked at various different states. For example, here, where if you plotted all those states on one single chart, it would be so dense with lines it would be impossible to read. But the small multiple layout gives us the granularity that we need. And last, we use tables. Tables are great, but tables can be enhanced, which is wonderful. And you can add visual enhancements and embellishments to encode information and make data tables easier to scan, which is important to think about when you're presenting information to consumers who demand all of the numbers. So as we think about how those things come together, we can create various different dashboards on customer satisfaction monitoring or a health question or community health, and you can look at lots of different information and data points in one place. And as we do that, we oftentimes try to make sure that we're following some of the same principles that we'll talk about as we look at a single chart on the context of a larger dashboard. How do you make sure that you're prioritizing the top level information someone needs first in the upper left-hand corner and allowing them to read down and across to see the various different data points? There's been research done looking at eye tracing studies at where we look on dashboards, and we really do, unless there's a distracting feature somewhere else, start in the upper left-hand corner. So besides thinking about the kinds of data stories we might be trying to illustrate and the chart types we'd use, we want to think back to that question of visual precision and form. How visually precise does your form need to be? And as we think about the relative comparability of different forms, it's very easy for our eyes to compare the relative length of the bars when they're on one aligned scale. But as we move across this kind of continuum over to more generic comparisons, it's harder to make comparisons of the area of the three smaller circles, for example. We can see that one of the four circles is much bigger than the other. But are the other three the same? Maybe, I'm not sure. And things like luminosity we use on choropleth maps all the time. And the important piece there is not to say that it's a bad encoding of information, but it provides us a more relative scale or ramp of information and should be accompanied by a really clear legend. Last, and the most important piece, and the place we start with many data visualization projects, is thinking about what will resonate with your audience. What information do they need? What questions are they trying to answer? And what kind of charts or graphs are they accustomed to seeing with this kind of data? So as we think about the ways in which charts have persuasive powers, we should think about how with great power comes great responsibility. And so we should recognize the fact that as we build charts and graphs, it's not just about making things that are pretty and doing the things we'll talk about next in terms of making nicer looking charts, but rather the fact that the more that you engage people through those beautiful, aesthetically beautiful visualizations, the more you engage them with information. There are researchers who have looked at the ways in which the presence and reading charts and graphs actually allow us to believe information more. This is one of the charts from a Washington Post article from a while back that talked about an experiment that looked at if the specific response was around the percentage of people who incorrectly believed that global temperatures have decreased or stayed the same over the past 30 years. And you'll see the two groups on the bottom in terms of the two categories were both among Republicans where this belief is more widely held. And so they looked across three different groupings of people in their experimental design. The orange are people who were given no information. So this is just their baseline belief in what they thought. The light blue are people who were shown a textual summary of the correct data. And the blue were people who were shown a chart of the correct data. And you remember that the way that they are perceiving this is around incorrectly believing something. So we want people's actual scores to go down. Down lower is better in terms of holding the correct belief around climate change. And so as you look at this, you can see that there's a massive drop-off between people who saw text versus a chart. And that holds across other research that's been done, that when we see the presence of charts and other chart-y things like figures or equations, we believe them more. And so remember that when you're making a chart or graph and presenting it to someone. So every chart that we make is created through this series of many small charts, and no tool is going to tell you what the best fit is for your audience. You have an important role to play in how you go ahead and you present and create visualizations. And so what I'd like to do is work through a really simple example of a chart, a basic bar chart. Let's take some sample data that I made up out of thin air, looking at how long have our members been part of our community for an amorphous exemplary example of a community that's out there. So let's look at what happens if we get a sample data set of the number of members based on their tenure by different groups. So if we see that we have somewhere a little under 100 members who've been with us for less than a year, somewhere a little under 300 who've been with us for 1 to 2 years, and so on across the different categories, this is the basic bar chart that pops out of Microsoft Excel if we go ahead and we build a basic bar chart. Now, this basic bar chart doesn't tell us a lot, and I have no idea what to do with it. This N at the top especially doesn't help me very much. So let's talk about what we can do to make this into a chart that actually communicates something. First, I will make almost every chart I make into grayscale. Get the chart shape right in black and white first, and then add color back in with meaning and purpose instead of letting your tool make your color selections for you. The first thing we'll do after we make that grayscale is to declutter our chart. Let's declutter all of the gunky gunk off that we don't need or the design defaults that the tool has given us. And here's kind of a walkthrough and a list of the things I'll look at and make deliberate decisions about, because the decision might be different depending on the chart. Do I need the grid lines? If I'm going to keep the axis, I might want to keep them or want to be able to allow a more precise comparison against a grid line. But if I'm going to directly label the bars themselves, I might remove them. Is there any rotated text? I'm sure we've all seen the charts that get made that have the text that rotates to the side, something more like this. We don't want rotated text, which typically happens because of long labels. If you have a really long label, like a survey question response, shifting to a horizontal bar chart would be a good alternative. But here our dimensions are such that we don't have rotated text. Do we need a legend? Right now we only have one data series, and the legend is kind of a moot point, so we can probably remove it. We may come back to bringing it back again later. What is the gap width between the bars? This, on a bar chart specifically, if you think about one design default to change, especially in Microsoft Excel, it's to tinker with the gap width, the space in between the different bars. And the default in Excel and in PowerPoint and the Microsoft Suite is 182%. So the space between these two bars is 182% of, almost double, the width of the bar itself. And what this does is create unnecessary pockets of white space that prevent us from easily scanning and making comparisons across those different bars. So we reduce it down to 50 or below, and we get this nicely clustered, easier to see the shape bar chart in terms of what those categories look like. We make a decision about using an axis or labels, or perhaps an axis and one label. But we're looking for the place in which we can think about where information might be encoded in multiple ways and make a purposeful decision on if that's necessary. You may want to keep it, and that's okay. From an accessibility perspective, especially, double encoding can be a good thing. But you should be making those decisions mindfully, not because your charting tool told you to. So let's go ahead and let's remove the axis and just do the direct labeling to look at the number of people in each of these categories. Then we think about how we interpret the data. Do we need a reference line or some other kind of information to compare these numbers to? And it seems like we're having kind of some slow starts on getting more people to join in recent years. That kind of under 1 year and 1 to 2 year range is pretty small. So maybe we should look at what we would have expected to have based on the number of members who have been with us for less than a year or for 1 to 2 years. And if we add that as an additional data series, for example, you could see that we have those shaded bars in the background that give us the expected number of members we would have if we'd met our various different targets for membership recruitment and retention versus the actual targets. And so we can start to give a little bit more context and see that we seem to be kind of short for reaching our membership goals for this under a year mark. And what does that mean? Is that because good charts oftentimes not just answer questions, they prompt more questions. Why is that happening? What can we do about it? Then we go ahead and we ask ourselves about the sort order. Here we already have them ordered from kind of the newest tenured group to the most tenured group. And so that makes logical sense. But you can also think about other ways to sort information: alphabetical, ascending, descending, other meaningful sort orders that are important to you. And then we think about text elements. Do we have the various different text components that we'll need to customize to make this chart really communicate an explanatory response or an analysis finding? And so we can see things like a chart title and a subtitle and adding in the data source. And I'll actually add these in Excel specifically as individual text boxes rather than adding them as the actual default chart title and elements, in part just because of the readability components. When you do that, you need to make sure that you add alt text as well, though, because of the fact that you're pulling things out of the default components on the chart. And then we can think about alignment. How is everything aligned and shaped? Is everything fitting in the space that we expect it to fit into if we think it's going in a slide or a PowerPoint or a report? And is everything aligned such that ideally we start reading in the upper left, our chart title and everything else aligns to that left-hand row. So here's our decluttered chart. Now there's more stuff on there now for sure, but we've removed some of the excess things that we didn't need and added in the placeholders for other information that we do need to make this chart communicate effectively, including having a spot for the data source at the very bottom of our chart. Next, we think about meaningful text. What text and information do we need to add so someone can effectively read this chart? And believe me when I say that charts are meant to be read. That's part of how we read information. We can look to see if we need an axis title or units that we could place on an axis if we had one. Here we might instead place it in the subtitle where we put the number of community members by tenure as of March 1st, 2023. Then we think about what our title is, and we can think about ways in which to use the title to write your headline. Think about how you can write what someone needs to know as the top of your chart. It's a great gut check to if your chart is actually communicating something that you want it to. It also allows people who have low levels of graphicacy or ability to read charts and graphs or low data literacy to still read that key takeaway at the top and know what you're intending. So what should your reader take away from your chart? Here, maybe we'll focus on member growth. So member growth has slowed. More than 75% of our members joined 3 or more years ago. Number of members by tenure as of 3/1. Now we have our clear title, which will help us eventually in figuring out what to highlight and kind of do when it comes to color. We also make sure we use things like visual hierarchy, not just in the marks themselves on a chart, but in the fonts we use. So using a different font size to denote the title and subtitle, with relative size denoting the relative importance of different pieces of information. I want your eyes to go here first and then to go here next. Then any other information needed. We haven't added the data source at the bottom, so we should probably fill that in, maybe community membership database from 2023. And now we have a chart that has all of the text components that we want for the most part. We haven't tinkered with our legend yet because we haven't made a decision about color, but we'll have to come back to that as an important piece of text to make sure that we clearly communicate what of each of the different bars mean. Last of those 3 steps, we think about purposeful color and how do we add color with meaning on that black and white chart. Thinking back to that example of looking at the 5s in the table, it's really important to recognize the power of color and the power of color and focusing attention. In a paper titled Declutter and Focus that was done by the Northwestern Visual Thinking Lab, along with Cole Nussbaum and Aflick and a few others, they actually tested people's ability to recall information they saw presented in charts. First on kind of a basic cluttered, really awful stacked bar where people were asked to redraw what it looked like. Then looking at a decluttered bar, 2 different side-by-side panels. And then last, a decluttered and focused bar. And what they found is that for the focused one, people were far more likely to retain the key point. Decluttering something made it look more professional and is a great thing to do for various different reasons. But when it comes to retention, that kind of focusing someone's attention with text and with color was one of the most powerful ways they were able to improve retention of information from the charts that people looked at. When we think about color, we think about different color ramps, sequential colors, diverging, categorical, highlighting or alerting colors as ways to go ahead and show information, use color differently, where color may be encoding information or just differentiating between different categories or sections. And we always think about color blindness and the challenges of using colors like red and green together, which we tend to avoid because we don't want someone who is colorblind to not be able to differentiate between the different data series. And when you look at contrast, it's not just about red and green, but looking at contrast, say, between the foreground and the foreground text and the background color, and making sure that when we're presenting information, that information is readable. And you can use tools like the WebAIM contrast checker, some of the Adobe color accessibility tools. We have a whole repository on GitHub of data visualization accessibility tools that I'd encourage you to browse that allow you to check and look at contrast. So let's go back to our chart. So for color, what story are we emphasizing? That should be in our title. Do we need more than one color to highlight different categories? And how has this color been used in other parts of our slide deck or dashboard? So we could do something like categorical colors for expected and actual and showing those 2 different layers. We could use an alerting color if we want to focus attention on the slow growth component. So member growth has slowed in those more recent cohorts that have joined us. Or we could go ahead and use a highlight where we highlight the bars that are actually being called out in our title in terms of more than 75% of our members joined 3 or more years ago. Here's where we continue to use that kind of bold color contrasted against the gray because we started in black and white. So if we stay with that approach and we highlight those 3 bars, we can start adding the additional annotations where we directly label the various components of our chart or graph to help to identify which sections are read in which way, rather than expecting someone to look at a legend and then track back to the chart itself. And we'll do some additional kind of finalizing and formatting of text to ensure contrast and readability. You can see you can add things like adding the additional color embellishment across the top and the title to go ahead and finalize and create a chart that communicates a message clearly. Then you do a final check. Does your chart tell the story that's written in the headline, reinforced by your text additions and color selection? The best thing to do is to give it to someone else and ask them. Don't assume that you, who's been staring at this chart for anywhere from the past 10 minutes to the past 2 hours, is going to have the answer to that. So ask someone else for input, even if it's someone else outside of your team, or maybe it's just your partner or your roommate at home. So here we have the start and the end, the initial chart that is spat out by Excel if we build a basic bar chart. And then what we have if we start to get more purposeful, meaningful decisions about what we highlight, how we declutter, how we use meaningful text, how we use purposeful color, which creates a much more compelling and easy to read chart. Now you could find a lot of different data stories in this chart too, right? And you could start to think about ways in which you might visualize the data differently. But that's part of that iterative process of data visualization design, and something that you really is worth spending time on in terms of tinkering and seeing what would resonate the most with your audience. So let's go ahead and close out with 3 sticky challenges and things that we think about in data visualization that I encourage you to think about too. And then we'll leave the remainder of our time that we have together today for questions. So 3 sticky things we're thinking about. Data humanism is one big piece. This idea that was originated by Georgia Lupi, who's a design partner at Pentagram, who talks about the importance of thinking about data as people, not just numbers, and focusing on small data and imperfect data and inspiring data. She did an amazing hand-drawn postcard project for 52 weeks with a friend of hers in the UK, where they mailed postcards about their lives back and forth of data they collected about their weeks and their lives. And those postcards are now inside MoMA in their permanent collection. And we saw this in the course of the pandemic, where we looked at the ways in which people tried to visualize really staggeringly large numbers. So this idea from the New York Times of listing out names and short snippets of obituaries, where the graphics team said, putting 100,000 dots or stick figures on a page doesn't really tell you very much about who these people were, the lives they lived, or what it means for us as our country to lose that many people. And as they moved towards the 500,000 mark, they actually went the opposite direction. And they used tiny dots, and they said, there's just a certain numbness, I think, around how long this has gone on for. And what's striking here is just the sheer speed at which it was all happening. So a totally different goal in terms of watching the speed of that loss as it goes down to the denser parts of the chart at the bottom. And then looking at the 1 million mark, where they chose to do a map. And what's staggering and striking about this map is actually that it looks like a population map, which in almost any other case would be exactly what we don't want. But here it reinforces kind of the universal experience of every corner of the US having been hit by COVID, albeit with different communities being hit harder in different ways. We also saw people who moved away from those kind of print or digital publications, like Suzanne Furstenberg, who did her installation of the In America flags, first with around the 280,000 lives lost milestone at the National Armory in DC, not too far from my house, and then across the National Mall, when we were closing in on the 800,000 mark. And I would argue that walking through the sea of flags gives a very different experience than looking at a page in a newspaper. And the flag approach has been used in other contexts. Right now in DC, there's actually a display around colorectal cancer deaths with blue flags. And along the edge of it actually are toilet seats, which if you think about colorectal cancer, toilet seats, with a lot of information and stats lining the mall around the same area that these flags were put down in. We also think a lot about visualizing uncertainty and how we do that effectively. We have this challenge that when we create visualizations, we imply a certain degree of factfulness and objectivity. And this creates a challenge when visualizing incomplete, messy data sets, like data on an emerging new disease like COVID, or new study data that comes out. And there are researchers at Northwestern and other spaces that actually research and look at how we interpret and understand uncertainty in information. I pointed to the example of the challenges around understanding summary stats on a bar chart and the underlying distributions and some of the deficit framing that can happen. But there's also ideas around how do we plot things where maybe we use individual dots on these dot plots instead of using a density plot to reinforce the people, say, underneath a curve on the flatten the curve graphic. Last, we think a lot right now, and I think this is a really good thing and a good evolution of the field around accessibility as practitioners. Unfortunately, I don't think the tool stacks in data visualization, especially the big BI tools, have really made our lives a lot easier in making some things accessible. But as we think about the evolution of accessibility conversations, we've moved away from what was the discussions were in the 1980s, for example, of disability as a personal attribute. And instead, now we think about disability as being context dependent. And we think about inclusive design, where the things that benefit one person actually benefit all of us. I never realized how few curb cuts were in my neighborhood to go up and down a sidewalk until I had a stroller. And then I wish there were more of them. I appreciate captions on videos when I don't have the ability to turn the sound up, even though I'm not myself hard of hearing. So it's important to think about the ways in which inclusive design benefits everyone. And to do that, we should think about the ways in which we recognize exclusion and we make sure that we are including people in our design from the start. When we solve for one, we extend to many. How the ways in which curb cuts for a wheelchair user also benefit new parents with a baby in a stroller. And we can learn from diversity and actually listen to people and their feedback about our work. So remember, as you think about data visualization and as you create your next chart, graph, dashboard, whatever it might be, that data visualization is a robust interdisciplinary field. There's plenty of history and resources to learn from, and each learning path is going to look different. But I encourage you to explore the tools that are most relevant to your work. Second, the many seemingly small design decisions that we make help charts communicate effectively. We focus on decluttering, using meaningful text, adding purposeful color, and many other things and decisions around the level of seriousness or whimsy and the preferences of our audience. If you focus on only those three things, decluttering, using meaningful text, and purposeful use of color, I promise your charts will get better. And last, when making a chart, consider the people behind the numbers, that data humanism lens, communicating uncertainty where you can, and prioritizing accessibility. So with that, I would love to connect with folks. You're welcome to reach out to me if you're interested in connecting with us on the Data Visualization Society. The website and the Twitter handle and such are down there. You can find us on all the social platforms. And you're welcome to email me, connect with me on Twitter or over email. And we have a big conference coming up at Outlier in Porto, Portugal, May 3rd through the 5th, as well as virtual. And we have a great hybrid structure and a great virtual platform where you can still do networking. You can still join and host unconferences, all kinds of good things. So I would love to see some of you at Outlier if you're interested in diving more into the world of data visualization. So with that, I stop sharing so I can see you all. Trisha, do you want to let me know what questions you got?
Yeah, so first question that I want to make sure we get to is, are you going to be sharing your slide deck?
Oh, sure. I can share a PDF of the slide deck if that would be helpful to folks.
Yeah, that would be great. It's being recorded too, which I said, so that's definitely there.
We hadn't talked about that before, so.
I'm looking at the in-person room. Does anyone have any questions? If you all have any questions, you can come up front and ask. For those of you in person, but for virtual, you want to come on up? All right, awesome. So Amanda, here's our first question in person.
Hi. Come on up to the virtual mic.
I can hold it up too. There you go. That might be better.
Thank you.
Uh-huh.
Hi. So thank you very much for the presentation. It was really great. I just have a question about how do you represent outlier data?
Outlier information, like data that kind of falls outside an expected norm?
Yeah. So sometimes there might be, a lot of information that tends to fall under a certain group of data, but then there might be some exceptions. What would be the best way to represent that?
It depends on the context and about what you're trying to present. So if the focus is focusing on kind of the overall distribution and range of values that can happen, I would oftentimes plot all of that and present all of that. If that obscures and makes it really hard to read what's happening in the smaller section, because it extends the axis out by 3 or 4 times as long, sometimes I'll do a zoomed in version that specifically shows what's been excluded, that zooms in on that smaller section on a more condensed axis. So say you're doing a distribution or B-storm plot, so that you actually have a section that zooms in so you can see all of those individual dots or points. I also, where it makes sense with the audience and everything else, would consider removing the outliers if there's a reason to exclude them, either statistically or based on the survey design. that there's a reason to exclude those data points from the visualization, but add a footnote to make sure that that's clearly noted that you've removed something from the visualization itself for readability. I think the thing not to do is to truncate the axis, or especially in a bar chart, is where that gets really, really tricky. Is if you've got one really long bar, like I know you've got the 4 big banks that make billions and billions of dollars a year, and then you've got tiny bank over here. Like, how do we make sure that we're maybe using not just one chart, but multiple charts to zoom in on those sections to see the differences? Otherwise, things could be really hard to compare.
Awesome. Thank you.
Yep.
Awesome. Thank you. So I'll turn to the chat next, but if anyone wants to come, do you want to come up and, okay. Well, let me ask this one in chat and then I'll go to you next. So hi, Amanda, could you share with us basic step-by-step data viz in our communities, which your presentation pretty much did. Is there anything that you'd like to add, Amanda?
I'm not quite sure on the question. Is it to, can we get a clarification on the question?
Yeah, Juan Diego, do you want to maybe kind of expand on that a little bit?
I'll in the session chat.
We'll wait and see if you can kind of expand on that. I'll move on to the next one. Anything that we should absolutely not do. Anything that makes you cringe when you see it. I like
you know what's funny is that like the obvious answers there that I think someone would expect me to say, I'm going to say that there is nothing I would say I would never do. There are things I thought I would never do that I've done. So let's take a couple of the examples that come up a lot and talk about them for a minute. So things that I would never do. The thing I would never do is misrepresent data and deliberately make a chart to lie to somebody. Big fan of not doing that. So I think if you're building a chart for the purpose of misleading someone, you should press pause and reflect and then not publish that chart. So that is the thing that makes me cringe the most, is when you see things that are deliberately misleading. We've had the unfortunate experience of losing a child, and I had content of mine misrepresented and taken out of context to promote an anti-vax agenda. And as a public health person, I've seen how that kind of content spins and gets spread. And so think about the fact that when you build that misleading chart and put it out in the wild, it can catch like wildfire in bad ways. So the things that people oftentimes say, they're like, these are the rules. We would never do these things. Things like pie charts come up a lot, and you should never use a pie chart. Save the pies for dessert. But there are contexts in which pie charts make a lot of sense, as do donut charts. In part when we want to be able to see a limited number of segments to maybe 3 segments. And the goal is to be able to compare against kind of the 4 corners-ish of a pie chart, the kind of 12, 3, 6, and 9. And Robert Casara has a really excellent video talking all about the science of reading pie charts, where actually they perform better in terms of our understanding of the information than stacked bars in some contexts. So I would never say don't use them. The other one we hear a lot is 3D charts, and I would certainly not advise doing an exploded 3D pie graph that has a really distorted way of presenting the information, at which point you're kind of misleading somebody. But there are times in which 3D charts actually are really inspiring. There's examples of charts that were made around, Gabrielle Marie did one. We talked about 3D charts on Chart Chat this morning, so it's top of mind a bit. But like looking at topographical maps and visual images of maps that look like they actually have 3D shape to them are really beautiful and engaging and interesting. So I would say there's nothing I would say I'd never do besides deliberately lying with a chart. And I would more so think about making sure I can explain why I've made each individual design decision that I've made on a chart or graph. All right, looking at this.
We've got
Juan Carlo. Did we get a clarification from Juan Carlo?
Yep, we got a clarification. Sorry, it's just share tips about building data viz.
So I would encourage you, if you're interested in diving more into tips about data visualization design, to join DVS, to get connected. We have free membership options as well as paid ones. So it's a great space to learn and dive into data visualization content. If this is specifically about reprising this talk or this information for another community, feel free to reach out to me over email, and I'm happy to chat with you or point you to ideas.
Awesome. So there's 2 other questions in chat, but we've got an in-person question.
Go for it.
You ask away.
Hi, my name is Mary Lightfoot. I'm here in the DC area, and I am currently having to give feedback on a dashboard with a whole bunch of charts and information. Yeah. My question to you is, when you're trying to determine what makes cognitive quick cognitive understanding sense, how do you determine how to represent that data, whether it's bar or graph? And do you have one or more resources to further explore that?
So I think I would point to some of the things I mentioned in the talk around thinking about levels of precision and looking at analysis goals, and those chart taxonomies can be really helpful there. I think with dashboards, one of the things that I tend to follow is the rule that we should keep the visualizations and the views rather simple, especially if there's multiple charts and graphs all in one single display. And where you can, think about ways in which you can follow the mantra of starting big picture first, then zooming in and filtering, then looking at the details on demand in tooltips or other spaces. The thing that kind of makes me cringe is when the table is right there at the top versus a chart that shows me the table. And so I oftentimes will think about what the goal is first. Is it more important to look at trends over time or compare a category, and then make my chart selection based on that? In terms of resources on dashboards, I think some of the best resources out there on dashboards from a book perspective are the Big Book of Dashboards or Show Me the Numbers, or I think by Stephen Few. Those are both good. The other one that I think is really great that's more someone writing about dashboard design a lot is Nick Desbarats, who did the box plot graphic that I had thrown up. He does a lot of work under the website Practical Reporting, and he does a lot of really great writing around decisions around chart selection in the context of reporting on information. I could dive into dashboards for like 5 days if you wanted to. So there's just a lot out there. And the biggest piece is user testing and focusing on what your user needs are, and are you serving their needs and answering their questions? Does every chart that's on that dashboard answer a question for someone? And that's kind of the place where I always start.
Thank you so much.
Yeah.
And okay, yeah, we've got another in-person question. And I guess you pretty much, Amanda, just answered one of the questions in the chat about resources. So I'll skip over.
Those are about dashboard resources. I'd point a little bit differently, I think, on database resources necessarily. There's a lot of resources and things out there. It depends on what you want to learn. If you want to dive into the world of interactive graphics, that's a different kind of world and set of resources than building better infographics that are static and more graphic design oriented. So it depends a bit on what kind of product Lisa is thinking about. Do you have a clarifying point there, Lisa? I'm pulling up a link to our resources page for DVS that you might find helpful generally, but was there a specific kind of data visualization product or stream or something that you're interested in?
So infographics mostly.
So if you're looking at doing infographics, I would focus on learning how to do some of the graphic design pieces of building effective infographics, rather than focusing solely on some of the other components of interactivity design. And so with infographics, I think that I would start from a place of, who's a good person who's infographics? There are not a lot of people who I follow who kind of sit specifically in the infographic space by itself, but I think that folks like Stephanie Evergreen and Emery with Depict Data Studio and Kolnas Pomerantlik with Storytelling with Data, they all write a lot about those very great explanatory graphics and making better explanatory graphics that you'd find on an infographic. I think looking at tools like Canva and other things are also really helpful for being able to build sleeker, better looking infographics that actually give you some of the kind of guides when you see the snap grid features and other guides that pop up on their site. But this is a list of just like favorite resources from our community in case this is helpful. There's a lot of things here in terms of what people like, and these are all community collected resources on things people enjoy. So you might find these to be helpful.
Awesome. Well, thank you. We've got another in-person question.
Sure.
Hello. Thanks
Hello.
for posting that link. That'll be really helpful. So my question is, when you're designing a dashboard, is there a sort of like a best practices for how many different types of visualizations you should or should not use? So, you know, if you're trying to avoid something like cognitive overload, should you limit it to just a spare number of types of visualizations, or is it best to try and stick with one and have like multiple, I guess, like categories displayed by the same kind of chart? Does that make sense?
I think it depends on what you're trying to show. And I think the broader question you might be asking that it relates to is more around information architecture. I think the mistake I see sometimes is people having this kind of very antiquated mindset that a dashboard has to be all the things above the fold on one page.
Yeah.
Rather than thinking about kind of what kind of groups of questions do I want to answer together, or groups of charts do I need together to answer a question. And so using things like a connected set of dashboards, like 5 different dashboards, but all in the same workbook, if you're working in a Tableau type space, where you then can go ahead and have some kind of navigation feature to move between them. And thinking about when it comes to cognitive load, how do you start with, again, big picture, then zoom and filter, then the details on demand to see the information you need. I think anyone who tries to put you in a box around, like, you can only have 2 chart types, you can only have 4 charts, like, you could find great examples that have more than those, and they're great, and they're really good dashboards because they answer the question someone needs. And so when I've worked on dashboards in different contexts, it's varied so widely. But I would zoom back and think more about information architecture. And we actually have a great piece from Lila Manum. I'll pull it up. All about kind of the role that you're not hiring for in your data viz team is an information architect. And she talks about that both from a back end and a front end perspective. And I think she has a nice job summarizing some of those challenges. So I would think more about the UX components there almost than the chart components.
That makes sense. Thank you.
Of course.
Awesome. Thank you. So I think we have time for one more question. So I'll go with the last one in the chat here. I think we were able to address all of them. You gave us so much to think about when creating. Thank you for someone. For someone new to data viz, is there a specific starting place, a type of chart or visual elements to explore at first?
That's a great question. So I think the place I would point you to, and this is on a Tableau link, but I would, if you're thinking about doing chart work, I think that practicing is the most important thing, right? It's really easy to critique charts. It's a lot more work to sit there with a blank page or a data set and build a good one. And so I would look to some of the ways in which there are various different data visualization challenges that have been stood up by different data viz leaders that you could engage in. So if you're brand new to data visualization, one that I like a lot is called Back to Viz Basics. And what they do is they post a simple data set and a simple chart challenge. So this week, make a line chart of this data. And they take away some of the labor of having to go source and find your own data. And then if you choose to, you can share back your visualizations you've created with the community and ask for feedback and get ideas and feedback on what to do. If you're looking for a book to read that is like the one book I would tell you to read, and I'm looking for it because it was in my room. The one book I would tell you to buy that we use for teaching our Data Viz Foundations class at MICA, where I'm an adjunct, is Better Data Visualizations by John Schwabish. If you're looking for like the one good starting place book to read, I would tell you to go buy this book. So the name of the book, you can go to whichever private bookseller you'd like to go to, but it's Better Data Visualizations. It's by John Schwabish. And it is one of the best primers that goes through things around cognitive load. It goes through pre-attentive attributes, Gestalt principles, different chart types, accessibility. It covers kind of the high level of all those things. And we actually pair it in our class with How Charts Lie by Alberto Cairo. And that is an excellent book to kind of focus more on the big picture of how we read and understand charts and graphics and some of those ethical considerations. So I would send you to that kind of set of open challenges. And if Back to Viz Basics isn't your jam, here is a list I'll post of all kinds of other challenges, but lots of open challenges that will give you specific things to work on. And I think that can be a way to get stuff when you're just learning, is someone giving you a prompt or kind of assignment to respond to. So that's where I would start.
Absolutely. Well, we are at time. Thank you so much, Amanda, for joining us. Everyone's clapping. We've got a whole room full of clapping. Yay! Awesome. Well, thank you again. We really appreciate it. We learned so much.
Of course. Thank you so much for having me, and always happy to connect with folks on data viz things. And my favorite question to ask you is like questions about your questions, such that maybe I'm not the right one to talk to, but someone else is. But I'm always happy to refer people to other folks and to resources, and excited to have more of these big kind of networking communities connecting up with each other.
Awesome. Well, so now everyone can head over to Venia's session. Do you remember, what is it called offhand? So yeah, if everyone goes over to the agenda, we have another virtual session coming up from Venia Logan that we're super excited to have her. What's in it for me dashboard approach.
See,
So
there you
please,
go. You know all about dashboards from Vinya.
exactly. All right. Well, we'll see you. We'll see you over at the other tab. All right. Thanks, guys. Thanks, Amanda.
Bye. Thank you.